Good day, everybody. The topic development of robust and easily maintainable grid-connected battery charger for developing countries was written by Ugwuoke, Eya, Candidus, you and Oladeji Matu Babatunde, and is presented by Dr Eya Candidus in this month of January 2020. So, introduction: grid-connected battery charger is a type of charger that steps down and rectify AC power as well as controlling it to charge battery storage device. The key function of battery chargers is to ensure long-lasting operation of rechargeable batteries. Rechargeable batteries have many places of application, like in communication and navigating devices, mobile polling media players, wireless deploy remote portable drilling machines, hospital-based storage power systems. In developing nations, damaged batteries litter around the environment due to improper charging, over-discharging of secondary batteries, and lack of advanced technical know-how. The way most of the developing countries repair faulty falling battery charger is to remove the whole panel and replace it with a new one. This increases the cost of maintenance and polluting the environment. Essentially, there are many chargers with different charging modes of operation, as we reviewed from 11 to 17. Like in one charger using constant steady voltage, that is CV, charger using constant current, CC, charger using constant current, constant voltage, CCV, charger or utilizing pulse charging. The aim and the objectives of the proposed system. The aim of this research work is to develop a robust and easily maintainable grid-connected battery charger for developing countries. Objectives: we have three objectives. One, properly combination of transformer, diodes, transistors, resistors, and capacitor in conjunction with mathematical models to realize the power circuits of the battery charger. 2, application of ZRT control scheme to ensure over-voltage battery regulations and protections. 3, experimenting the proposed systems. When these three objectives are carried out, definitely we are going to realize our aim. In methodology, here we have in figure 1 the proposed power circuit diagram. It consists of the voltage source, the transformer, the rectifier, the LM31 subsection of the charger, and transistors and transistor coupled sub-circuit of the charger, and they are connected to the load. So how does it work? When it supplies by the VS to the transformer, the transformer will now steps the voltage down to 15 volts. From the 15 volts, it is now rectified as once the AC relay is closed. It will now the rectifier will now rectify the AC power to DC power. Then the DC power is used to activate the LM317 and the transistor inductor subcircuit. But in charging of the battery, it depends on the rates of a battery. If the battery has the current rating of 0 to 2.5, the LM317 charges. But if the current is above that, the LM317 will now shut down. The transistor coupled inductor will now enable the current to charge the battery. So that is how the operation of this thing works. So the proposed control circuit, we have this scheme. This scheme is called ZRT, battery control scheme. So when the VA, the VB, VC, and the VD are supplied with an isolated 12 volt battery, 12 volt isolated voltage balancing voltage are is supplied to VA, VB, VC, and VD. What will happen is that the current will flow from VA through the R7 to activate the T2, and when that is activated, the current will now flow from VB through the collector of T2 to the emitter of this to the base of T3, and when that thing is done, the current will now flow to the ground, and that will now place 0 at the base of T4, and when that thing is done, the current will flow from VD through the T4 to close the relay circuit by drawing that lever to NO that is normally open. But once the lever gets to that place, it will now close and it will now start charging the battery. So and when that thing is done, what is happening there is that the Zener diode will be monitoring the level of the battery voltage. If the battery voltage is not up to 14, is not greater than 14.4 volts, the charging will continue. But once the battery voltage is more than 14.40, then the ZD, that is the Zener diode, will break down, and once it is broken down, it will act as a resistor. And once it is acting as a resistor, the current will now flow from the positive terminal to the RT, and from the R5, as in R5, to the base of T1. And once that is done, the current will flow from VA to the R7 to T1, and from T1 it will now go to ground. And when that is done, what is going to happen is that at base of T2 and T3, the voltage there will be 0, so they will not be conducting. At VC, through the VC, the current will now flow from VC through R9 to the base of T4, and as a result of that, the 12 volts are placed at the base of T4, and what will happen is that the T4 will not be conducting, and once it is not conducting, the relay circuit will now go back to normally closed. That is, it will be disconnected, and that is how the voltage is being regulated. So this is experimental setup results. In figure 3, it shows the unenergized state of the proposed system. Figure 4 shows the transformer output waveform with the proposed system. Then figure 5 shows the rectified output voltage waveform, and that rectified output voltage waveform consists of the AC component and the DC component. And when that thing passes through the filter, it removes the AC component and allow the AC power to energize the LM317 and the transistor coupled inductor subsection. So the filtered output voltage of the charger is shown in figure 6. So from that figure 6, we now move to figure 7. Figure 7 shows the 11.6 VDC battery voltage from the digital meter with the proposed system. Figure 8 shows 12.23 VDC battery voltage from the digital meter. And from figure 8, we now go to figure 9. Figure 9 shows 12.25 VDC battery voltage from the digital meter. Figure 10 shows 14.36 VDC battery voltage from the digital meter. So the figure 12 shows 14.4 VDC battery voltage from digital meter with the proposed system. So once the voltage is above this 14.40, definitely the Zener diode will be broken, and once it is broken, the AC relay will be disconnected and the battery is safe. So when it recovers, it continues monitoring, or when it recovers and the battery voltage less than 14, less than 14.40, it continues charging the circuit. So that is how the high voltage or excess voltage is being regulated as far as this particular charger is concerned. So achievements and conclusion. One, analytically, for the first 40 minutes, that is in figure 7 and figure 8, there was a rapid in charging the battery which showed voltage gap of 0.63 volts. Thereafter, the voltage gap slowed down to 0.15 volts. Subsequently, it rose to voltage gap of 0.16 volts until the battery voltage closed 14.40. So 2, the system is highly robust and can withstand voltage stresses. 3, it can easily be repaired in the case of any faulty situation. Finally, I recommend it most especially for the developing countries due to the lack of advanced technical know-how. Thank you for listening. I am now waiting for your questions to give you answer. Bye.